Hey everyone, thanks for joining us. My name is Arvind. I'm a partner engineer here at Hex.
And my name is Gabe. I'm a developer advocate here with Hex.
Today we're doing our third installment of Extreme Makeover Edition. We'll be looking at how we can take a Hex project and supercharge it with Snowpark. We'll be acting as two data scientists working for a large utilities company, looking to explore our company's energy data and find any analysis correlation to move the business forward. Let's jump into it.
Let's go. All right, so here I am in a brand new Hex project, and I want to just get started by pulling in some energy data into this project. So I can go to my data sources, and these are all the data connections I have available to choose from, but the ones that I want to use are already pinned. So I'm just going to select my energy data and query this, and let's remove this limit 100 just so we can get all of our results into our project. And all right, pretty cool. So this energy data is basically broken down by 10-minute intervals, and it's showing us the total power usage per state based on the region. Now, I want to get a better picture of what this data looks like, so I'm going to go ahead and visualize this in a chart cell, which I can do. Actually, before I do that, I'm going to change this to say energy data. And then let's go ahead and visualize this in a chart cell, which I can just hover over my output variable, click visualize in a chart. And I want to see this data based on the date time, and I want to group this by the month. And then I just want to see the average power usage grouped by a state level. So let's close this data browser as well. And once the chart loads, so now this is a bar chart, but I actually want to have this be a line graph. So let's change that. And based on this line graph now, we can see all of our data for each state, and it looks like Colorado is using up the most energy for this data set, and this may come in to be really handy later on in our analysis. So now that I have my energy data in here, I don't really want it to be as granular as it is right now. I kind of want it to be more on the day-to-day level versus the 10-minute interval. So I'm going to go ahead and create a new query, and I'm going to use data frame mode since I want to create this energy data frame. And I'm going to go ahead and copy in a query that will convert my date times into just date objects. So let's run this cell. And okay, so looks like we have an error. Okay, so this seems like this might be something that Magic can fix for us. So I'm going to go up to Magic and hit fix. Let's let Magic think for a little bit. Yes, okay, that's right. So we have to cast date time as date before we can run this query. Okay, so I'm going to keep that because that looks good to me. And let's run this cell again. All right, perfect. So this data looks exactly how I want it to be. We have our data now on a day-by-day basis, and we no longer have those 10-minute intervals. I'm going to go ahead and change this to say actually daily energy data. And now I want to pull in some other data to find any correlations between power usage and weather. So I have another data set that I've pulled from the Snowflake marketplace, and let's just get that queried into our project. And let's remove this limit so that we can actually pull in all the results. And let's run that cell. All right, so it looks like this query actually took about a minute to run, and it seems like it actually crashed my kernel, which is pretty unfortunate because I really wanted to work with this data set inside of Hex. But I think I actually know one of my friends who can help me out with this problem, so I'm just gonna go ahead and leave him a comment in this cell. And I'll just give him some time to respond to this and wait on him. All right, man. Well, thanks for coming in and helping me out with this because I was just trying to pull some data to Hex and it ended up crashing my project. So I'm just trying to figure out how I can work with this data set.
Yeah, let's go ahead and take a look. I'm going to go ahead and resolve this comment to start. So I think we have a good way to work with this data set.
Okay.
If you haven't worked with Snowpark before, I think that's a great alternative, a great use case right now. So I'm going to go ahead and create a quick Snowpark session here. What this is going to do is actually piggyback off of the database connection you have created ahead of time. So I'll minimize this just so we can have a little bit of cleaner view. And I'll run this cell. Once this runs, actually, what's going to happen is we'll get back a Snowpark session. This is what's going to allow us to actually work with Snowpark data frames for the rest of this project.
Okay.
So revisiting the cell that actually crashed your entire project, what I'm going to do instead of returning this as a default pandas data frame, I'm going to select a Snowpark data frame instead. And we'll see what happens when this runs.
Oh, snap. It didn't crash.
Yep, exactly. Do you know why it didn't crash?
No idea.
Okay, so what's really happening here is a concept around lazy evaluation. That is an idea with Snowpark where I can actually use a SQL cell like this or a SQL query, whatever sort of query I'm making on a Snowpark data frame, and it's going to be a lazily evaluated. And what that means is it's actually going to act as a pointer in Snowflake. So this query right now is actually just giving back 10 rows of data. So instead of bringing back, almost a billion rows here into hex memory, which is going to crash your kernel, we're just going to bring back a preview so you can actually see with it, work with the data, get an understanding of what's going on. What this query is actually doing, and on the Snowflake side of things, is actually just acting as a placeholder or this pointer. So once we actually want to do some sort of action call, that's when we'll actually execute and things will run against the entire data set. But up until that point, we kind of have the keys to the kingdom on how we want to work with this large data.
Oh, that's pretty cool, actually.
Yep. So let's go ahead. I'm going to rename this to weather data. Like so.
Baseball weather round.
Thank you. Go ahead and do that. At this point, I'm looking at information. It sounds like you're after average temperature. And it looks like this variable name is something of interest because it has maximum and minimum temperature, some snow depth information. So we should probably do some cardinality checks on this column. So I'm going to go ahead, and before we do any checks, I'm going to make a new Python cell at this point. And what I want to do is actually grab some code that gives us a extra large ability to run on an extra large warehouse. Okay. So I'll copy paste some of this stuff in here. And I'm going to enable a extra large warehouse. I'm going to resume it, and I'm going to go ahead and call it at that point. So let's run this. And at this point, we're going to work on an extra large warehouse. And because all of this is actually happening on the Snowflake side of things, we can leverage our scalability and compute at this point because all of it's being handled on the Snowflake side of things.
Okay.
So going to a new SQL cell, let's do that cardinality check, where I'll go ahead, I'll paste in some more text here for us. A SQL query that is actually going to return back all of the variable names here that have the word average in them, just so we can see, hey, is there an average temperature that we want to get back? And I'll make sure to return this as a Snowpark data frame. So we can go ahead and run this. Sweet.
Oh, nice.
It looks like we got some data back here. So this is an average temperature variable name, and that's probably what we want to do. The other thing to call out here that may be confusing is you probably use Snowpark with pandas. Is that correct?
Yeah, I have. I was just about to ask, how are you using Snowpark in SQL when it's only like a Python package,
Yeah, definitely. Yeah, that's a good question. So this is kind of why I like the Hex's integration around Snowpark, because it actually provides an abstraction for people like you and me who maybe have been using SQL a bit more in our careers, where we can go ahead and leverage a native SQL cell within Hex, but it's going to do a wrapping for us so we don't have to understand all of Snowpark until we actually want to use it. And we'll showcase some advanced use cases of this with our analysis. I have some ideas that I think you'll like later on the road.
Okay. Cool.
Yep. So continuing with this, right, we now see that we actually care for average data. And I've actually used this data set before with a past project. And the way this is actually gathering information is based on a weather station level. So there are many different weather stations across the whole globe. This data is globally captured. But if we go back to your earlier data sets here, if say we look at Colorado again, there are many different weather stations within the state of Colorado, right?
Yeah.
So we're actually going to grab a new data set that is going to be kind of an index table that captures all the information around a particular weather station. So I'm going to go back to our data sources again from that Snowflake marketplace. I'm going to get this weather stations index. I'm just going to do a query on it. Let's remove this limit. And again, since we're going to work what seems to be really large data, I'm going to go ahead and return this as a Snowpark data frame again, just so we're staying consistent. We can leverage all the flexibility that I like to use in Hex here. Great. So we got back. It's clearly not as big, but this is nice since we have a Snowpark data frame. It's going to have that lazy evaluation I talked about. And as we explore this data set, right, we can see we have weather station information. This column correlates or is primary and foreign keyed to this column. Okay. And what we're going to see here with this index table is we have things like the country name, the state name. That's probably something that's going to be of interest for us.
Yeah.
And then also some other information that we maybe don't really care about. So at this point, what I'd really like to do is join those two data sets. And I'm going to call this weather stations, just so we're keeping our naming convention the same here. So let's go ahead. I'll create a new SQL cell at this point. I notice this whole time I'm actually chaining some of these data frames together, and they're actually Snowpark data frames the entire time. Lazy evaluation is being used, right? I'm not actually having to run all of the select stars until I really care about it. And a moment that I care about was something like the cardinality check above right here, right? And another example of what we would call an action call when you're working with Snowpark data frames is something like a join, right? Where we actually have to get sense. We have to see, hey, what's the country name column here? And we're after just the stuff in the United States.
Right.
And it make things consistent. And then since we're working with really large data, let's go ahead and use Snowpark again. You'll notice my source for this cell is my Snowflake connection. So I'll run this. Awesome.
598 million rows in 3 seconds, though?
Yep, exactly. So I'm going to go ahead and call this again, for continuity's sake, US weather data, and we can continue on from there. So the next sort of thing is obviously filtering down to the states. Since we don't cover all the US within our utilities provider, what we can go ahead and do is just filter this US weather data down to the 6 states that we have from above. So I'm going to go ahead and actually go into a Python cell at this point. And let's leverage some of that data from the energy data frame above. At this point, what I want to do is just grab the unique state names. So we saw from the chart you created above, we had like Colorado, Wyoming, and some others. So let's see what we can do with this. And you'll see how we can actually tie this together in a second.
Okay.
All right. At this point, I want to make a new SQL query that is then going to filter down all my US weather data. So it's just grabbing the information around these 6 states.
Okay.
But the reason I actually grabbed this list right here called states is I'm going to leverage something called Jinja. I don't want to hard code these 6 states because I think we were actually looking at exploring Arizona next. I remember that was in a company all hands that we were looking at. So what I'm going to go ahead and do is actually pass this list here. I'm going to define that it's array. So basically the Jinja knows that, hey, I am passing in a list or an array into my SQL statement. And at this point, I'm also going to return this as a Snowpark data frame. So similar, you can do this with a regular pandas data frame in Hex. Pretty neat because you can actually do this all with a Snowpark data frame.
Oh, wow. It's pretty intense.
Yep. So I'm going to go ahead and change this name. And let's call it something like states weather data. I think that should make sense. But to highlight my point earlier, right, if we look at the state name here, we have something like Wyoming, right? But you'll notice Wyoming actually has multiple weather stations here. We have 3 just in this preview. So we probably want to do an aggregate on the state level. So I'm going to go ahead and create another SQL query where we're going to reference the state weather data at this point. I'll go ahead and create a new SQL cell. We're chaining again. And I'm going to reference this state weather data, right, which is in fact a Snowpark data frame.
Okay.
And let's go ahead and see what this gives us. And I'll make sure to, again, select that this is a Snowpark data frame. And I think it'll make a little bit more sense as we explore this data.
Yeah.
Sweet. So here you can see we actually group things on the state level, and we don't have the column anymore that actually shows us the weather stations IDs because we actually, if we go to the example of Wyoming, right, this SQL query here is actually giving us average of the value column, which is in degrees Celsius at this point for the state level. So I grouped it by the state and the daytime. And the daytime here is on a daily basis. And I think that pairs really well with the work you did above by getting our energy data on a daily basis as well.
Sure.
So as we explore it, right, we have degrees Celsius at this point. We have our daytime and we have our states here. So we have a state name of California. And let's go ahead and just call this something like weather data cleaned.
Okay.
I think that makes sense. We can continue with our analysis then. Sweet. Looks good to me.
Yeah, me too.
Let's go ahead. We'll create a new chart and we'll grab this weather data cleaned variable from above.
Okay.
And let's do a line chart at this point. Something like this. And my x-axis will be the daytime, just like we did above, right? I'm going to continue with your theme around monthly aggregations.
Okay.
And I will use degrees Celsius. I probably care for an average at this point.
Okay.
And then I'll group it by the state name, just to say with the theme that you did above.
Yeah.
So the grouping here and this aggregation is actually being pushed down into Snowflake.
Oh.
So this is kind of a pro tip for yourself if you are working with kind of like 1 billion rows of data and you want to get an aggregate. You can actually leverage these chart types, the native ones here, but still get the benefit of like an extra large warehouse. Alrighty, so let's go ahead. We probably don't care for degrees Celsius since we're within the states.
Yeah.
This chart's a little bit busy, so maybe we can clean this up a little bit later. Okay, so at this point, I'm going to create a new SQL cell, and let's add that degrees Fahrenheit column that we want. That looks Pretty good. Yeah, that's definitely, I recall that's the formula for the conversion. I'm going to go ahead and keep this here, exit magic. Let's make sure we're actually returning with a Snowpark data frame to stay consistent as we're exploring this. Go ahead and run this guy. Sweet. And again, to highlight, this is all happening inside of Snowflake. So if we look at even the memory in the project, right, we haven't even used about a gig of data at this point. Right. So you're not having to worry about the scale of your data that you work with within Hex. Okay, that looks pretty good to me. So let's call this weather data final. I think we don't need to process this anymore at this point. Looks like we have data that goes back to 2000. So that's great because I don't think our company's weather data goes back that far. So we have a good leeway there. So let's call this weather data final. So let's continue on from here. And what we probably want to do at this point, since we have our energy data that has been finalized and we have our weather data that's been finalized, we probably want to join those two data sets together so we can actually see how things correlate over time. So I'm going to create a new SQL cell at this point, and I'm going to grab your daily energy data, and I'm going to grab this weather data final that we just kind of dwindled down from the data we found in the marketplace. And at this point, I'm actually just going to leave it to return as a pandas data frame. I'm going to make sure I select a data frames type here as well. Okay, so we can go ahead and leverage that. So let's go ahead and run this. Sweet. Now we have 10,000 rows back. I personally like doing this because I don't really have to worry about, am I working with a Snowpark data frame, working with pandas, right? I can actually just kind of leverage this native SQL cell and then go ahead and just use, or basically join a regular data frame to a Snowpark data frame. And since we're working with, just 10,000 rows of data, it's about 2 megabytes. I'm just going to bring it into Hex memory at this point, since we don't need to leverage our large scalable compute.
I don't think 10,000 rows will crash your project.
Yeah, exactly. So at this point, I'm pretty happy with it. I'm going to call this final. Okay. Would you agree with that?
Yeah.
I think we have everything. So we definitely have, our dates here. We have our state, the region, the daily power. I define this as megawatts just to clean it up a bit. And we have our degrees in Celsius and Fahrenheit at this point. Sweet. I think we should probably visualize some of this at this point. Just to give something that we can share to our stakeholders later on. So let's go ahead. We'll create a new visual, create a chart here, and let's use the final data frame. I'm going to go ahead and create a line chart. So we're staying consistent. Definitely want this to be aggregated on a monthly basis. We'll stick with our date x-axis. Daily power we certainly want, but I'd rather have an average. And let's initially recreate what you've done on the state basis. Okay, that looks pretty much exactly what we did above, but I really want to see some weather data at this point. So I'm going to add a y-axis to the right, and let's do a line chart again. I'm going to bring in the degrees F we calculated. Then I'll go ahead and grab an average, and I'll group it by the state so we're staying consistent with the left y-axis.
Ooh.
Okay. Yeah, a lot going on. That's a little bit busy. Let's style this so it's a little bit more legible. I'm going to go to our second series here, and let's make this dashed to start so there's a distinction, and we'll change the opacity to, let's say, something like 35 maybe. See how that looks.
There we go.
Okay, that's definitely a bit cleaner. Let's explore this a little bit. We look at, say, Colorado. Oh, yeah. You see that correlation?
Yeah.
Definitely. So if we look at some of these, okay, here's the summer months, it seems, going to about 2019. We definitely have a spike in temperature in the dotted line. That's correlating to a spike in energy consumption. The winter months, yeah, here's January. There's February. Yeah, certainly there's a strong correlation. That would make sense. I mean, Colorado has 4 seasons. Yeah, I like that. That's something we may want to add. What do you think, to a report or something?
I think so.
Okay, I wonder how we could actually create a report, but maybe you can help me out with that later. Cool. All right, so the next thing I'd like to do that I'm thinking about is we may want to do some sort of model or something. What do you think?
See if we predict future.
Yeah, I think there'd be some stakeholders that would really be interested in having a model that can predict basically the future power consumption we have in our states.
For the temperature.
Yep.
Yeah, I think that'd be really cool.
I'm going to go ahead and work on that a little bit, and then I'll share you some code, and then we can add it to this project. Done?
Okay.
How's that sound? Okay, let's do it. I'll see you soon. Okay, so I gone ahead and actually created an XGBoost regressor model.
Okay.
So we can go ahead and leverage this. I actually packaged it up into a Hex component.
Okay.
Pretty easy. I'll just add a component. This is that XGBoost regressor. Make sure to click it. I'll import it. Give it a second here. Cool. We have all of the code brought in. So here's kind of my regressor. I'll go through the details around this. And at this point, this is still in what is called like the component form. So as I scroll back up, here's that chart that we created earlier. I'm actually going ahead and eject this into the project itself. Okay. So if you ever do want to edit this for one reason or another, you can actually edit them as individual cells in your project. Like, you're not tied to the component anymore. Okay. But we save that component. So, you know, if we make another project, if we make another project, we can still use the carbon copy.
Okay.
Original.
Actually, I'm about to use components all the time now.
Yeah, they can be handy for sure. So I'm going to go ahead. So these are running, but let's make sure we're running them cell plus downstream. Okay. And at this point, we'll run everything in these ejected cells that came from the component. Okay. All right. Well, perfect. Now we actually had all of these cells run that have been ejected from our components. So let me talk you through them, at least at a high level, bringing in a bunch of functions and different data types. What I'm doing in this particular Python function is I'm actually taking and adding more features to our data set so we can get a better model as we work through this.
What's SPDF? Snowpark data frame?
Yep. Oh, okay. Exactly. So I'm using this as a Python function. So I'm going to pass it a Snowpark data frame at this point, and we'll return back, of course, the Snowpark data frame that we've modified here. Okay. I'll show you how this looks in a second. So I'm going to take that final data frame, which was a pandas data frame, and convert it to a Snowpark data frame and add in some of these features, which are basically just new columns. I'll show you that in a second here. Okay. And this is really nice because then we can leverage Snowpark ML. So all the machine learning is actually going to be happening inside of Snowflake. So again, as our data scales and whatnot, we can actually house it inside of Snowflake. So it's not just living in memory somewhere.
It's still using that extra large warehouse we defined from earlier?
Yep, exactly. Nice. Exactly. So we can scale. When it comes to inferencing, it can be really, really handy.
Yes.
So great. At this point, I actually spoke with some of our stakeholders. They actually cared for modeling on a state-by-state basis. Okay. So to start, I've gone ahead and actually just looked at the state of Colorado, since it was our highest using power, our highest power consumption. Yeah. And long story short, basically, you can see the different types of features. So I actually pulled out the day of the week, the quarter, the month, just so we can give the model more inputs to see if we can get better results. Okay. And then I made a train and test split, and these came back as Snowpark data frames. So we have kind of it's a common flow of machine learning where we want to have some training data. And then when you actually evaluate it, right, you want to evaluate it onto new data sets. And that's where the testing data comes into play. Yeah. And I use another visual just so we can actually see what the training data looks like here. We have our daily powers expected, degrees C and F. And then these are the other features I added, like day of month, week of year, right, monthly, quarter information, so on and so forth, to try to help the model perform better. As we scroll down here, I needed to perform a standard scalar on this, so everything is on the same scale. So we can quickly do that. And this is actually now leveraging the Snowflake ML library. The neat thing about this for us, honestly, is we don't have to run all this locally for one, because it runs in Snowflake. But I actually prefer using Hex for this stuff because all the package dependencies are pre-installed. So cool, I did this on my training and test data. Let's go ahead and just run this real quick. And we'll look at training features. So it's the same data above, but this is basically the output. Yep, exactly, the scaled data. So I'll go ahead, continue from here. And this is the actual regressor here. I won't go into details about all this, but as you're reviewing this, I would recommend using Magic here to explain some of this stuff. Okay. So long story short, we're using XGBoost here. I won't go in details here, but I'm actually going to keep this because I think this could be helpful. Cool. Yep. And then from there, I'm now going to, train the data, or I'll fit it on my training features. Then I'll do a predict. So this is basically saying, hey, we've trained our model on our training data. Now let's go see how the model performed with our testing data set. Cool. So I'll pass in the test features. And this is the output of the model from Snowflake. Okay. So you'll notice we have all of those regular features that we saw. We have our daily power. But the thing to highlight here is we actually have our predicted power as well. And now I want to see, how did this model actually perform, right? That's kind of most important. So I'm using mean squared error, and I'll actually use root mean squared error. Okay. This is neat to do because the actual mean squared error will be happening inside of Snowflake since we're grabbing it from the metrics module. And then
Snowpark or Snowflake ML.
Yep. This is still using Snowflake ML, exactly. Then I've gone ahead and just done this basically a root of the MSC, which is the mean squared value from above using NumPy. Cool. Makes it a little bit easier to do it. Yeah. I made these single value cells just to show you how I did that, right? We could go ahead, add the value, and it's grabbing this from MSC from above, right? This is the root mean squared error coming from here.
Yeah.
Then I actually wanted to visualize this really quick. So here's that predicted data frame visualized. The orange is the predicted value, and the blue is the actual recorded value that we had.
Pretty close, actually.
Yep, the model seems to be performing pretty well from a visual inspection. And as we continue here, what I would like to do is actually combine the training data with the test data. So you have a kind of a full lineage. I did that with some Snowpark code here. Again, you can use Magic to explain it if you need. But I made this combined data set where we actually see total power for Colorado. So it matches the exact same chart that you did above. But I overlaid it with this model predicted daily power. So we actually see, you know, from the start, the model maybe wasn't performing that great. Maybe we want to investigate that a little bit more, see if we can get better model performance here. But after that, it seems like it's actually tracking pretty well on the fall and spring months. And maybe there's some issues around the outliers. So maybe we want to relook at our metrics, kind of explore this model a little bit more detailed. I think we can go ahead and maybe create an app.
All right, so I think this logic is looking pretty good. I think I'm ready to make this to an app. But first, I'm going to add a title and description using Magic. All right, cool. That looks pretty cool to me, and I'm ready to arrange my cells.
Before you actually go to the app, can you show me how you add some of the visual components into the app view?
Yeah, no problem. So if you want to add a new cell to your app, literally just click on this Add to App button. If you want to remove it, click on the same button. Good.
Cool.
So in the app side of things, I'm showing a single value cell with the total power usage for this month when compared to last month, and I'll also make this full screen. And then here I have a correlation of the total power usage when compared to the temperature, and I will actually add a title to say total power versus temp. Simple enough.
And you just double click?
Yeah.
Actually editing the cell notebook side?
Exactly. Adding the cell from the notebook side. And so we have a pie chart just showing us the total power per state. And then here we have the model performance section. And actually, I'm going to add a text cell just so that people who are looking at this can get an idea of what this is actually showing. So this is going to be model performance, just like that.
And is this a text cell that gets added on the notebook side then?
Yeah, so the app cells are also linked to the notebook. So if I click on view a notebook, it should bring us right there. Right here. Yep. So we have model performance right before those cells that we added. So I think this looks pretty cool, and I think I'm ready to share this out to the world. So I'm going to hit the share button, and I'll just make it public as it already is right now. Oops. Public like this. And I can hit this publish button, and it will run my whole app, and then be ready for me to push it out to the internet. All right. So it looks like our app is ready to be published. We have all the cells that we saw in our original project, and all I need to do is hit this publish button, and anyone can take a look at it. And we can even view the published app with this link right here.
And this is shareable because it's shared with the web?
This is shareable to the web. I can hit this little copy link to the published app. And now anyone I want to share this app with will be able to see exactly what I'm looking at right now.